This conference will now be recorded.
Yeah.
Hi, everyone. Yeah, I'm new, fairly new to OCP, and I think this is my first time with this group call. My name is Alua Suleimanova. I'm a sustainability program manager at Marvell Technology. It's a semiconductor company and based here in Santa Clara in California. Great to meet you all.
Say the company again.
Marvell Technology.
Oh, not Marvell. Okay, great.
Yeah.
We were wanting other semiconductor reps in here, so welcome. You are
Thank you.
Definitely welcome.
Thanks.
Did I get your name spelled right here? I think there's an I in there.
Yeah, there is I between E and M.
All right, very close.
Correct. And Marvell is with double L. Thanks.
Next item is that we have a new wiki page. So I went ahead, the homepage was of OCP still hasn't really been updated to reflect the current work streams. I did hear that there was some activity around that. I don't really know what it is, but what I went ahead and did is I'll drop the link into here, but I went ahead and on the OCP wiki, I created a new sub-wiki page for us because I am frequently needing a place to point people to tell them what we're doing. And there wasn't a good place to do that. So work in progress, happy to have other contributors to there, but I wanted to make sure everybody knew it existed. So here's the OCP wiki page. You go onto Open Compute and you get to that wiki and on the sustainability one. And then there's a new category here for our work stream, carbon modeling, carbon data in the data center. And then there's a new sub page. And I'll be putting our meeting notes here and our recordings going forward here. But there's a meeting page, a new page, which should be blank now because it just created it, where we can start to kind of frame out and add more specific content for our work.
How I can access this document?
What's that?
How I can access?
I just dropped the link into the chat there.
Okay, good.
Yeah. Okay, any other business items? Is everyone going to check, because this was an issue last time, everyone know how to subscribe to the meeting correctly?
Hey Scott, also this is Vijay. I'm trying to call in over here.
Oh, hey Vijay, how's it going?
Hey, I may have to drop off once the flight starts boarding, but I'm just listening in.
No worries, no worries. Yeah, so Vijay's on the phone call. I'm driving today's meeting as part of our tag team code leadership, since he's traveling, but yeah. So the next agenda item, Deb was going to give a quick overview. I felt this was important. Deb did this a couple of weeks ago, and then because of scheduling, we couldn't get it scheduled till today. It was important to kind of set some framing and some thinking for folks about some of the inputs and some of the gotchas when we're framing how we're actually going to, where the data comes from, so that we can capture how you transfer the data within the context of the supply chain and the data center. So I think Deb had some really good content she's going to go over right now. So Deb, I'll hand it over to you. Let's see, I might have to.
I need to be made a presenter.
Let me try that. Let me make you a presenter. Oh man, I don't know how to do it. I want to be. Maybe I have to stop presenting first. Hold on, let me stop presenting. Okay, here. Stop sharing. Okay, now Deb, can I make you a presenter now? Yeah, there you are.
Okay, let's see.
Okay, Deb, you should be able to.
Alright, looks good. Screen of main monitor 2.
And Rich, maybe if you're new, while she's pulling it up, if I haven't captured your info, maybe you can drop it into the chat, just a short intro, and I'll add you to the attendee list.
So, leave the meeting now. How do I move these things around? I don't know. People, can you see, or are
You're in PowerPoint, yeah.
these, okay, so these windows are just blocking me, not you. I think one thing that maybe, I don't know who was present for what parts of the discussion, but so one thing that we decided, we had originally divided things up more based on the function that's seen externally. So we had a networking portion and a memory portion and a storage portion. So what we decided to do instead of that is to just talk about ICs all together in one place, because in the end they're all built and packaged the same way. So just have one section that covers all ICs, be those ICs DDR, SSDs, server, NICs, talk about them all in one place. And then anything that's specific to any of those horizontals that we talked about, like networking, like perhaps there we would talk about the embodied carbon in fiber, or something, something else, cables, right? Something else that's specific to networking. Likewise for storage, maybe there we would talk about tape drives if we still use those, HDs, etc. So that's sort of been a little bit of reorganization. So in order to talk about that, and I probably should make this a little bit more clear, is that, so for integrated circuits, we're going to talk about the fabrication, the wafer fab, making it even more clear. And then the packaging up of the die from the wafer fabrication with other components. And then we added daughter cards, so that way DDR DIMMs would fall under this umbrella. If you have a AI accelerator that plugs in through a daughter card, FPGA, a smart NIC, so we would be able to cover that whole universe. So that's sort of the intention. Yeah, so this is sort of the caveats for the smaller group that we talked through last time. So, we did have the first talk, and it's, it seems like maybe this is going to stick to some degree. But we definitely want input. Not everything that's stated here is a complete agreement with the current white paper draft. A lot of this reflects what I call the roll your own current state of affairs, where there's modeling to create carbon numbers for every step in this process, the wafer step, the packaging step, etc. So I don't think we're going to align everybody to use the same exact methodologies. So instead, the idea here is to lay some metadata along with the embodied carbon number, so that a user would understand what is and isn't included, what is and isn't modeled, how things were modeled, etc. So I did, to think this through and kind of come to my conclusions, as I used the Climate Disclosure Project reports from some representative companies all up and down the supply chain. But I would like to say I'm not a supply chain and operations or manufacturing professional myself, although I have interoperated with those people for many, many decades. But this is my impression in some way, and my employer takes no responsibility for validity of this information. If I name a company in a supply chain that does not infer my company does or does not use that particular company in our supply chain. So just to give an overview of what the basic steps are and the basic parties that are involved. So in other words, from a GHG protocol perspective, discussing our boundary for this embodied carbon report and for the metadata associated with it. So if you start on the right, optionally, there could be a daughter card for the examples that I discussed earlier. And so from the daughter card, we would then be able to get some enumeration of the different ICs that are associated with the daughter card. Otherwise, if it's just a server that's going directly on the motherboard, we would start like in this place that says IC vendor number 1. So for the IC vendor, this entity would have their own scope 1 and scope 2 that would need to be modeled, allocated, etc., to one particular IC that then you are asking for data about. And likewise, if there's a second vendor or a 9th or 10th vendor that provided ICs onto the daughter card, that vendor would be responsible for their own scope 1 and scope 2. So then for each IC vendor, I didn't draw it out for everyone, I just drew it out for one. There would be upstream from that some sort of an assembly and test entity. That entity could be owned by the IC vendor, or it could be very popular is this outsourced assembly and test, OSAT. But this, and sometimes you'll see this referred to as ATM, assembly and test manufacturing. So this is where all of the wafers are taken together, as well as a substrate, as well as a heat spreader, as well as some other little jelly beans that need to be associated. And it's all soldered together at this step. So this facility would have its own scope 1 and scope 2, again, that it needs to find some way to account for, some methodology to account for that, and then some way to allocate it across the millions or perhaps billions of parts that move through that assembly and test every year. And then upstream from the assembly and test, there would be some number of wafer fabs for each part. So that would be in the assembly and test scope 3. And then also would be, other than the wafer, the rest of the ATM upstream scope 3. I do want to point out this is a deep supply chain on the order of hundreds of first order suppliers. And first order suppliers, the definition of that is that they would exchange a bill with the assembly and test. So that's a first order supplier. But then if you go further up the supply chain, all the way back to raw materials and raw chemicals, etc., it's in the order of many thousands of companies. So, for a company that, so let's just leave that as where that is, and then kind of trace up the wafer fab part of the supply chain. So again, each wafer fab would have its own scope 1, its own modeling for how that is measured and reported, and then its own upstream scope 3. So here things kind of jump up by an order of magnitude in my experience. So we could say thousands of first order suppliers and probably tens of thousands of other companies if you move up the chain. And likewise, if this particular package includes, like for example, if you bought a GPU, one entity would have made the kind of the computing parts of the GPU, but a whole other fab would have made the high bandwidth memory that's packaged in with it, right? And so their, their supply chains are different. There may be overlap, there may not be, but just kind of the problem of wafer fab N understands some things about its first order suppliers, but if it does include in its carbon estimation further up the supply chain, that's not based on a one-to-one relationship where they know the name of the companies in that beyond the first order of the supply chain. So typically this would be done by some sort, if it's done at all, would be done by some sort of an EEIO type of reporting, etc. So this is sort of just an overview of how the pieces fit together. What this is I apologize, this is not a great slide. It's just a whole bunch of words. But again, just to remind everybody is that our goal is to have an API. And based on that API, we'll give an embodied carbon number, and then we'll give a bunch of metadata that describes how that carbon number was created. One thing that's good about doing it this way is that there would be clarity in the methodology choices that were made, or if a vendor doesn't, just says, I don't know for this any particular piece, that would also be communicated. And so it would also really help people to understand is that if I see vendor number one says my, let's say GPU embodied carbon is 1,000 kilograms, and company number two says my GPU is 10,000. Why are those numbers so different? And if you look at the metadata, you could see, oh, one of them really couldn't go much beyond the assembly and task phase, whereas the other one could reach much deeper into the supply chain, understand a lot more about the various ICs that were included, and perhaps even modeled all the way back to the raw elements. And so therefore, it's a much more inclusive modeling. So therefore, that's why their numbers were so different. One thing that will happen is vendors will be able to show the value of their sustainability investments. So a vendor that has worked very hard on greenhouse gas abatement, that should show up in this metadata, and they'll get credit for it if they've been spending on renewable energy. That should show up as well. And then there's a whole bunch of other possible things that this could give us over time, but I won't go through those. The non-goals are more what I saw as I'm kind of what I think IMEC is trying to drive. So we're not trying to drive any of those things. So I see this as complementary to IMEC. That's my opinion. We can certainly talk this through. And then another thing that's I think pretty important is that I tried to hew very closely to the greenhouse gas protocol, just because it's such a widely used and accepted standard, and it's going to give vendors the capability to repurpose data that they are probably annually reporting elsewhere and use it for this purpose. So let me stop here. I've gone through a lot, and I'd be open to questions. Comment.
I had a quick question, Deborah. Shruti here from Microsoft. And I was actually going to clarify something. So this particular API would provide the embodied carbon number, but then we also said that we sort of see this work complementary to IMEC. As far as I understand, IMEC is directly into the trenches of getting the embodied carbon. So how are we getting the embodied carbon here then, if we are not going into any of those portions?
So this could be my misunderstanding of IMEC Shruti. I read through their, I don't know, white paper or what have you. Seemed a lot of what they're trying to do is what I listed here. Drive improved use of renewables, more abatement technologies, green chemicals, supply chain engagements, informed choices at the product architecture phase. If they create a methodology for reporting a carbon number, so say that, again, let's take our GPU example, like say that A100, well, that's more than just a chip, but like NVIDIA T4 or what have you, right? They would, if NVIDIA hewed to that methodology and stored, for every part that NVIDIA offers, they stored it. Let me just go to my next picture, actually. So say that, it's possible that one of these databases is an IMEC database, or it's an NVIDIA hosted database, or it's the Semiconductor Consortia hosted database, but all of these databases would hold embodied carbon numbers. And so we're not assuming that everybody is going to go to one database and use one methodology for reporting their embodied carbon. So kind of the point of our API and our schema, our metadata schema, is that we can go to any of these places, pull out the data into one common format, and share it from there. So this should be, and again, one of the important pieces of the metadata would be for every step down the supply chain to describe what modeling was done. So, it could be if you used IMEC modeling for your wafer, but some other methodology for your test and packaging and test, and some other methodology for your daughter card. You could, at each phase, it would describe what methodology was used. And then again, I would expect within every methodology, there would still be parameters or things of interest that you could further reveal what choices you made within each one of those methodologies. For example, like IMEC is driving abatement technologies, but that doesn't mean everybody will have implemented them to the same degree in the same year. So that would be something, that could be surfaced through this metadata if the provider chooses to reveal that. If they don't, then, as a user of the data, you would kind of have to say, oh, this company, has great abatement technology, and it's, described and, through this metadata. This other company didn't choose to tell me one way or the other about their abatement, so, I'll assume they're middle of the road or typical or what have you, right? So we're trying to be, get as much clarity as possible and be as open to different methods, just as long, but ask them to expose the method.
Okay, I get it then. Okay, so we can take the data from any of these databases. It could be an IMEC database, etc. But the final format, we are sort of trying to equalize the final format that a user would see.
Exactly.
We're focused mostly on the schema and enabling the use case and the API, and acknowledging that there's no uniformity in the methodologies or any desire to consolidate the data storage. So, and trying to account for that.
Exactly.
Okay.
So this next page is meant to give an overview of the schema. So it's basically the same picture we already looked at. It's just I drew the supply chains a little bit more cartoony. So basically, if we were to take an overview of the schema, is that at the daughter card assembly and tasks, again, this is optional. Many things are delivered without a daughter card, but if it is included, there would be one of them, and associated with that would be a bunch of general information in the schema, the scope 1 for the daughter card assembly entity, a scope 2 for the daughter card assembly entity, scope 3 information, and then would be what I call the subpart declaration. So there's an IC enumeration that would say, if it were a DIM, it would say I have 8 of type micron XYZ, however, you know, whatever the name is of that. And I also have, you know, these jelly bean parts, or you know, maybe there's some other little controller that sits on that daughter card, etc. So all of those things would be enumerated out, and then we would use that enumeration either to go to a different database, or within the same database, go and find all of those ICs that were enumerated. And then for those, look at the ATM for that, and then it would go through the same set of information, the general information for ATM, scope 1, 2, 3, and then we would have a chiplet enumeration, because we're putting more and more small chips in one package. And again, those could be from many different manufacturers, so they would all be enumerated, and perhaps different databases would be tapped to give information. And then for each chiplet, likewise, it would go through all the scope information for that chiplet.
So, Deb, just to follow on to Shruti's original question, and based on this flow, so if there was a company that was that had wafer assembly all under one company, and they were just in the end they were just selling a daughter card, then schema, you know, and the so the schema would still, you know, it would still be the same in terms of you would be using the row number 1 for the kind of information that they would need to provide.
Well, so Micron would be a good example of that, right? When
yeah, Micron or Samsung for that matter, right?
Yeah, right. So, but yes, it would still, there would be one schema entry for the daughter card, and then it would enumerate all of the ICs that sit on the daughter card. So sort of like
would they be then required to do both row number 1 and row number 2, or only row number 1?
So it would be their choice, right? That, you know, they will, how can I put it? We would like them better. The more data they give us, they might opt
to do only one.
Just to do one. I mean, we're going to have, as we discussed with Scott in that other meeting, we'll probably have things that are required, things that we heavily suggest they include, and then things we wish they would include, right? So, you know, but in the end, they can return what they're going to return. And if, you know, if they opt to only give us information on their daughter card and not tell us what ICs are on that daughter card, you know, then the usefulness of the information could be called into question. But, you know, maybe over time they would come back and, you know, and give us more information about the IC.
I see. So maybe
Just
there's a data quality piece to it, is that, hey, if it's this, then, you start with the daughter card, but then your data quality is better if you, there's a hierarchy of data within that daughter card that you want to call out. I don't know if you want to make it a required or not, or a, suggested data set to go with it, which is rows number 2 and 3. Right.
right. I mean, typically the way that these things occur, right, is that, and we know this very well from our own experiences, is that, the companies, for, valid and not valid reasons, are
Right.
somewhat skittish to share the information, but then over time, their customers will ask, ask with varying degrees of emphasis or emphasis, or I'm not saying the right word, being more and more emphatic, like, if you want to be our supplier, we need you to share this information, right? So that would, be the motivation to share more and more, right? But I think in the other, on the other end of the spectrum, if we require everybody to share everything, then we'll never get off the ground.
That's right.
So, so the idea is to have the framework so people can kind of see, all right, here's what here's what people would really like to see in the fullness of time. But for now, here's what I'm going to share. Right. So, and again, there's information that is not accessible, right? Depending on where you sit in this flow, there's always going to be something where right? You can't. Nobody can go all the way back to the raw metals, right? Or the
Yeah. I was thinking mainly like as an OCP standards working group, right? That's kind of the recommendation we are trying to make here, right? Is that, hey, let's start with row number 1 and then go down row number 2 and 3. If you don't have everything in place for row number 2 and 3 today, but sort of put together a roadmap for doing rows number 2 and 3 in a future release.
I think we might want to approach it a little bit differently. I think we might want to divvy it up not by like the or recommend. I think we want to recommend, like, I think in this, maybe this is what Shruti is referring to in the comment. I think we want to recommend try to ensure you're accounting for a certain large percentage of your embodied carbon. That would be a
which would mean we want them to go back to the chiplets.
Yeah, do we have liaison to other OCB groups like ODSA and HPC? For example, ODSA, they discuss chiplets and maybe energy consumption for chiplets and from various vendors. Do we need a liaison with this group to find out what they are doing and how we can benefit from it?
So we're probably not going to do energy consumption, like, because that would be operational, which we've put out of scope for now. But so we're just trying to really focus, get that manufacturing phase nailed. But I agree. I think that's why Jim and that's why Rich are here to help kind of coordinate with some of the other groups.
Yeah, but the manufacturer of all of those chiplets attends the ODSA meeting and they can provide you with information about the energy needed to manufacture this chiplet.
Is that what you're referring to? Okay, maybe.
Yes.
So you're referring to the scope 2 information. So right, I mean, actually,
I'm talking about scope 3. It's scope 3 for not scope 2.
For each step, right? So the IC vendor has a scope 2, the assembly and test has a scope 2, the wafer fab has a scope 2, the suppliers have a scope 2, right? It's all in the context of, it's scope 2 within the context of what's being reported here, right?
Yeah.
And so, in general, we would hope that all of those manufacturers are someplace putting the information into a database, and then we would be, and from looking at our schema, they would see what we're interested in seeing beyond just a number, right? And hopefully they would be adding their electricity consumption at the various stages. Maybe it would help if we double click into the details. So I'm going to go right to the.
Hey Deb, can you just leave me 5 minutes at the end? Because I want to make sure we have a chance to check one on the white paper. So.
Yeah. Yeah, so this just gives you some idea of what the metadata could look like. So I will start putting this into the white paper and add columns that explain what each one of these would be, and whether it would be recommended, highly suggested, or optional. But you can see, right, for the manufacturing of each chiplet, there would be that organization scope 2 would be one of the things we would want them to break out, if possible, and we would want them to discuss what method did you use to allocate all of the energy that your factories consumed over probably a year. It'll probably be how they do this. How are you then taking that energy and allocating it to this one little chiplet? And then also we would offer them the opportunity to give both market-based and location-based information.
But should we also distinguish between clean energy and not clean energy, like?
So there's the market-based and the location-based. So for location-based, we would ask them for what carbon intensity they used and what was their source of that
That's
carbon.
important. That's important when you do carbon modeling, yes.
I'm sorry, I did not understand.
No, when you talk about carbon modeling, carbon dissipation, carbon emission, we have to differentiate between clean energy and non-clean energy.
So so there's the carbon intensity used and the source of the carbon intensity. So I do not know of any fab that is 100% powered by renewables, but if they have renewables on site that power them 100%, we'll find some way for them to communicate that in the location based. But again, I'm taking this from the GHG protocol, so they can talk about, if they're giving a market-based number, how that market-based number was.
Hisham, just so I understand, are you asking how are we doing this modeling of electricity into carbon intensity? Is that your question?
We would be asking them to fill out the schema with this information. How did they?
So when you fill up the schema, some of the data has to indicate the source of the energy. That's all.
So, right, typically it would be the grid carbon intensity. But we could say and or percent of on-site renewables. I mean, we could put something like that in there to cover this.
Okay, any final things you want to wrap up with? Deb? I want to make sure we just have time.
I'm done.
All right. Any last questions for Deb?
I have a question, but I tied it about storage.
Sorry, Shruti, you cut out a little bit.
I said I have a question, but I'll tie it into when you come into storage updates. I'll just tie in there.
Great, let's do that right now then. I will share the screen. All right, here we are. So here's the white paper. So the ask a couple weeks ago was everyone to try to get it to about 50%. I'd say we're pretty close. for the sections that we have anything. So as a white paper as a whole, we're probably 50% there. So we still have the intro, still looking for additional feedback, comments on that. I'm not gonna read it to everyone. I'll send out the link in the notes to make sure everyone has the actions. There's the framing that everyone was supposed to think about. Now Deb's done a great job taking her content, what she just did, and kind of creating a white paper form here. And there's a few other things we've called out. We don't have any networking stuff yet. And then the storage stuff is here, I noticed. There's the beginnings of the storage section. And Shruti, did you want to say something about this then?
Yeah, so two things actually. So one is we were trying to reach out to Ross via DJ, if you remember, to actually get some storage vendor expertise who could us build this. But I think finally we just decided that, okay, let's at least start off with, having some sub-components and what is basically building HDDs.
Yeah, are you still looking for that person then, Shruti?
Sorry?
You're still looking for that person to help then?
Yeah, so we spoke to Ross, and I don't know if James any better suggestion. Ross actually mentioned he is trying to reach out, but it will take a few weeks to align and get somebody involved.
But JM, are you the right person to maybe help out here?
Yeah, it's your lucky day because I'm presenting in the OCP storage workgroup on sustainability in 1 hour.
Yay!
Great.
Yeah, I know the folks. Oh, sorry. Yeah. I know the sustainability folks at Seagate and WD extremely well, so that's should be.
Great. Yeah, I think the ask is we just need some domain expertise to help scope out the white paper, which is really just the framing. So Shruti and JM, maybe you can kind of connect offline. Does it sound great? All right, perfect. And then so I'll send this out to comments, and then and just trying to get built up here. Was there another comment?
Yeah. So one more thing on storage. Now that we discussed how this looked for ICs, basically packaging and all those resources, I'm just wondering, does that mean that for HDDs it is going to represent the HDD level and then the subcomponent? I'm imagining that is what it will do, but I want to cross check with other.
I think like Deb said, we're trying to ensure that, think of it as we build the foundation in terms of the framing for the ICs, and so nobody else should really have to talk about ICs, and then everyone else can focus then on the things that are beyond the ICs. And so does that answer your question?
I think I am basically asking about how would this API work for, say, HDDs or tape. Just like in ICs, it goes from the card level up to the chiplets, up to the entire details. It goes back.
Yeah.
Does that mean for HDDs, it would be the HDD level and then it would go back to each subcomponent? Or I'm trying to imagine till what level?
I think we're making it a little bit too. So HDD and SSD are very, very different. For HDD, it's 3 vendors, and one of them is very good LCAs, like extremely. It has very, very good LCAs, and they report scope 1, scope 2, and scope 3. So at least we have one member of OCP who has like demonstrated that they can do this pretty good. So just take them as a case study. And then SSD is a whole other beast because ideally you want to be able to compare NAND made in one fab versus another. You want to compare the carbon intensity per gigabyte, standardized across different, capacities. The NAND flash takes the majority of embodied carbon in the SSD, so it scales with capacity, it scales with litho. That's much more complicated. Hard drive should be pretty easy, actually.
Okay. In terms of the format, I was thinking SSDs would automatically follow the kind of API format we are talking about in the IC section.
Correct.
But the HDDs, because it is a different format, that's why I was sort of wondering, will this follow the format of an HDD level and then subcomponent level? But we don't need to necessarily answer that right now.
Well, I would
Yeah,
say
I think we're not to get to that level of detail, just kind of like frame out the scoping, but yeah, we'll work on the format in the second half of the year. But yeah, go ahead, Deb.
yeah, I would just say that you guys, as the experts in this area, should do what makes the most sense rather than, I don't think we need to have every single thing be exactly the same.
And we can rationalize it once we get it, all the initial ideas down. Yeah. Okay, so I think the next ask is for folks to try next week to provide comments in here and for the subsection owners to take it maybe to like a 70%, completion so that we can try to get it fully done by end of the month. So, sound okay?
Yeah, I'll keep adding content myself.
Hey, Scott, also just in terms of, sort of what we are doing, should the title of this white paper be different from just carbon modeling white paper? Right, because that, oh, there you go.
Carbon data in the data center white paper.
Perfect.
We can edit the title. That's just working title. We can find out. It should I think the white paper should really be about like what kind of problem are you trying to solve. So yeah, happy to take more feedback on that. I didn't work too hard on the title yet.
Yep.
So, okay. Good meeting everyone else to know the notes and the actions, and thanks Deb for the great presentation.
Thank you, Deb. Thanks, everyone.
Thank you,
Thanks,
folks.
guys.